So for today's lecture, we're going to look at standard deviation. And standard deviation is basically a symbol that looks like this, right in there. It's a standard deviation. It's a measure of how spread out the data set is around the mean. So the closer it is, the smaller your standard deviation will be. And it's just basically figuring out how far apart your data is. So if you want something that's consistent, you're looking at something for a smaller standard deviation. So instead of listening to me, I'm going to have you guys look about someone else teaching graphing calculators using standard deviations with your TI-84s. Lots of times you can hit a YouTube video of many different teachers teaching it. Hopefully you can hit a good one. Here is a great one. I'll just have you take a listen here.
Here we want to find the mean and standard deviation of the following sample data. Now it's pretty easy to find the mean and standard deviation of sample data when you're given the data in a list format like this using the TI-84. Now, there are multiple ways you can do this. One, you could go ahead and put all of this data into a frequency distribution, because notice there are data values that are repeated. Or you can just put it into the calculator the way it is. We're going to do the latter, okay? So what we're going to do is we're going to start by hitting Stat and then Edit. And we will enter each of the data values individually in here. And notice we will just go ahead and do 12.3 each time that it appears. Okay. Now, when you're entering this stuff in, make sure that you hit Enter after each entry. Also, if you have data in here and you don't want it, you can hit Clear while highlighting the L1 or L2 if that's what you have. Okay, so let's say you put all the data values in, then you're going to hit Stat again, then go over to Calc. Now see, the first thing says 1 var stats. Well, that stands for 1 variable statistics, which is what we are working with, so you press Enter. Well, right now this is a function that your calculator will perform, but you need to tell it what data values to perform that function on. So we placed all of these data values in L1. So after we see 1 var stats on our calculator, we want to put L1 here so that it knows to perform the operation on L1. So we hit second, and then notice above the 1 key is L1. Okay, after we do that, we press Enter, and we get lots of information here. We get the mean, which is represented by X bar. So the mean in this case is 11.55. Now notice here there's an SX and a sigma X. Now because the sample and population standard deviation are going to be different, there are two different values. Okay. Now because this was a sample, we are going to use the one for sample. So S is equal to 3.45. Now if it had said population, we would use the sigma x1. Now even though there are two different variables for mean, depending on whether it's a sample or a population, this is going to be the mean regardless of whether it is a sample or population. Now one thing that I always suggest to do is to check and make sure that this n is correct, that there are exactly 10 data values. That way you know that you entered everything, entered them all in. Also, you can scroll down and you can find other things, like you can find the minimum and maximum data value and the quartiles from the data value. So this is a very useful function in your calculator.
So when we come back here, we're going to deal with population standard deviation. So that's going to be the one where we have the sigma. So where she used the S, we're going to use the one that was right below with the sigma. So let's take a look at some examples and decide which thing we might want to choose. So Randall wants to adopt a cat from a local animal shelter. He's looking to adopt a Persian cat or Burmese cat. He searched 10 different internet sites for their lifespan. His results are shown, the Parisian lifespan and the Burmese. Which breed should Randall adopt? So we're going to pull out our calculator as well, and we're going to hit Stat and Edit, and we're going to edit List 1. I've got lots of stuff in List 1, so I'll come up here and highlight L1, and I'm going to hit Clear, and then pop down. It deletes everything that was in my List 1. So now I'm going to enter 11, and then enter 13, enter 14, enter 15, enter 15, enter 16, enter 18, enter 14, enter 13, enter 14, enter, and it counts. So right now I'm highlighting L1 11th spot, so my last spot was L1 10, so that was the 10th number in List 1. So I'm going to do List 1, but I'm also going to enter List 2, but it looks like my List 2 disappeared and I have L3 sitting here. So I will put mine here, or we could go and get our data and then come in and type in our Burmese one. So I'm going to go 15, 16, 10, 14, 16, 15, 18, 15, 11, and 16. I'm entering on List 3, number 10, so I've got 10 in each list. So if I hit Stat and I go over to Calculate, Variable Stats, mine pops up as List 1 right away. It's a little different calculator than her, but I wanted to do List 1, and I hit Enter, and then I'm on the Calculate button, I hit Enter again, Variable Stats. So my average of this Persian is 14.3. So my X bar is 14.3. For my Persian. So that's the average life of them. But what is my standard deviation, my population deviation? So when I look back up here, standard deviation was 1.79. Okay, and all those other stuff is there if we ever do need it, but right now our sigma for this thing is 1.79. Now, I might want to carry on, and I want to look at List 3 next, because that's where I entered my Burmese stuff. It really depends on your calculator and what you entered, right? So if I go back to my Stat, and I hit Calculate, Variable Stats. Now, I don't want List 1, I want List 3. Not just 3. Second L3 comes up as List 3, and now I want to calculate it. So my Burmese, 14.6, but a standard deviation of 2.28, right? So my X bar is 14.6, but a standard deviation of 2.29 for my Burmese. So when I look at this, they both are very similar in lifespan in years. However, there's a bigger span of the Burmese, so I have a chance of it dying sooner or later, a bigger span, whereas this 14.3 for the Persian is very roughly span, and we can even see that in our range, right? If we picked our biggest number, subtracted our littlest number, our range is 7 for the Persian, and it's a little bit bigger. It's 8 for the Burmese, but they're a lot more widespread in the Burmese than the Persian. You'll notice that in the Persian there's lots around the 15, 16, the 14 happens lots of times, where on the other ones we've got just a widespread, there's not so many consistent numbers over and over again. If Randall wants to make sure that he definitely gets his 14 years, or roughly his 14 years, I would guess he should pick his Persian. But if he wants a chance of having a cat that lives slightly longer or dies slightly earlier, maybe the Burmese is his results. But if we're looking at what's your most consistent answer, your most consistent answer is your Persian. Okay? So let's look at one more example here. It says we've got a group of students. Oh, sorry. I need to erase all that. I'm on a Word document right now. We've got a group of students, group 1, group 2, group 3. Determine the mean and the standard deviation, and then which group performed the best. Okay? So the basic thing with this is just getting to learn how to enter lists in, how to delete lists. So I'm going to come up into list 3 and hit clear. I'm going to go down, and then I'm going to go over, up into list 1 title, hit clear, and then back down. So if I type these all in, I can end up with the mean and the standard deviation very quickly. So 10, 12, 10, 9, 8, 10, 12, 14, 15. That's 9. Was there another one? No. So there's 9 numbers in each. 1, 2, 3, 4, 5. Yep. So 9 numbers in group 1. So we can come up with the mean by right away going statistics, calculate, variable stats. Now I want to know about list 1, so then I have to go second L1, enter, enter, enter. So I get an average of 11.1 books read with a standard deviation of 2.18. So we could write 11 books, standard deviation, and get that in. When we're thinking about perform best, well, we're looking at the best average, but if they're all very similar for the number of books read, what's the most consistent? Maybe. Okay? So consistent would be the one with the least amount of standard deviation. So let's go about and enter some more lists, I guess. So I'm just going to write down group 1. My X bar is 11.1 and my standard deviation is 2.18. And I'm going to go and enter my other 2 lists. Okay? So I'm going to go statistics, edit, list 3, might as well enter. We get 12, 8, 10, 11, 12, 9, 9, 8. What's my last number? 10. And I'm going to go over into list 4 and do my group 3 thing. 11, 13, 12, 10, 7, 9, 9, 9, and 12. Enter. So if we go second statistics, no, not second statistics, just statistics, over to calculate variable stats. We want L3. That'll be my group number 2. My group number 2, my variable stats. Okay, so they read less books, right? Group 2, on average, read 9.8 repeating books, so about 10 books. But the standard deviation amongst their group members was smaller, right? So, yeah, they might have read less, but they each did a closer amount of the same books, right? So even if we look at the data, they all read more consistently the same amount, right? So if we look, they're all around a closer centralized digit. They're all closer to 10. Whereas this 11.1, we've got like the 8s and the 15s and the 14s. That makes it a little bit further away from the mean, and that's why our standard deviation is a little bit larger. So let's look at the statistics of our last list. That would be, in my case, list 4. Your guys' case might be list 3. It just depends on your calculator and what that title heading was that you put the list under. So 10.2 is group 3. X bar is 10.2, and our standard deviation is 1.812. So which group performed the best? Some people will say group 1 performed the best because it's got the greatest mean, but like really what's the difference between an average of 10 books or 11 books read? I like the quality of the sharing or of the ability to do this whole this work right here, this group 2. I think consistently their group members did equal amount of work, where well, we've all been in those kind of groups where some people do more work than others. So it depends on how you want to explain it. Some people will say group 1 did the best, they got the best average, okay? Other people might say, well, group 2, they read about 10 books, but their group worked consistently together. They each took their part and did their own part equally, or as equally as best could actually happen, okay? Now, there's a couple more questions, but I think you guys get the idea. When you're comparing things, if they actually end up having the same mean, then they're equal unless you look at their consistency. But like, if you just want to know, like for example, this question here says, which person picks more bushels of apples per hour? Well, I would look directly at my mean, my X bar. Which one has the better average? That's the person that picks more bushels of apples per hour. But who is most consistent? That's not necessarily the one who picks the most. It's the one with the best standard deviation because it is the closest. Its data realm stays very close to that mean or the average number. Okay? So take a moment, read through some of these key ideas so you know what's going on. Okay, and you can do that. It's right in your notebook. And I'm going to give you a couple questions here for you to work on. So here's your assignment. It's page 233, questions 2 to 12. Your choice, odds or evens. So you either choose all the odd ones or all the even ones, whichever one you want to cover. And then tomorrow I'll deal with any issues or problems that come up. So good luck in your working.